Hi students, welcome to the video lectures of software engineering. So today we are going to talk about flow-oriented modeling. Okay, so what is flow-oriented modeling? So basically, data flow diagrams can be used to complement the UML diagrams and provide additional insight into system requirements data flow. Got it. So it is complementing the UML diagrams, which means it is going to provide you some kind of extra information, even complementing the existing UML diagrams. Okay. So, so simply to say, this is a technique, okay, which focuses on how the data moves through a software system. Okay, let me mention here. So it's a technique that focuses on how data moves through a software system. Okay, this is what is a flow oriented modeling says. Okay, so the flow oriented modeling will help us to visualize the flow of the data through various processing elements in a system, and it basically focuses on the input, transformations and outputs where that occur as data passes through a program. So you can see the diagram which is also given here. You can see the input and a computer based system and output. Okay, so where the data flow diagrams, DFDs, here can be used to complement the UML, right? Where the DFD will take the input, process and output view of the system. Understood? So this means the data objects will flow into the software and transformed by processing elements and resultant data objects flow out of software. Okay, that is what the input process output view of a system. Clear, students? So that is what is flow oriented modeling. Okay, this is a technique which focuses on how the data moves through a software system. Clear? So this flow oriented modeling is, it's one of the oldest to say. Okay, oldest, and not only oldest, it's also the most widely used modeling approaches. Clear? So this model is a process centric and data focused one, and especially useful for your understanding the system functionality. So before we dive into the coding part, so flow oriented modeling. So you can see here, so components of the flow oriented modeling are given. One is external entities, then processes, then data stores and data flows. So external entities are, I'll write here, the sources or destination or the data. Clear? Like for example, you can say the user or any other system. Then processes, where this transform incoming data into outgoing data. For example, like calculate or validate. Okay, students. Then data stores, which will hold the data for a later use. For a later use, like any files or any database, we can say. Right, students? Then about data flows. Data flows are arrows that represent data movement. Okay, data movement between what? The entities. Entities are what again? The users. Okay, between the entities, processes, and data stores. So these are the four key elements which forms the part of your flow oriented modeling. So now if you observe, as we have already discussed, flow oriented modeling, where the DFDs are key, the data flow diagrams, which are used as to complement the existing UML diagrams, which tries to provide us with the additional insight, right? So now here you are seeing context level DFD, which is also called as level 0 DFD, that is DFD 0 diagram we call. Here also it's represented level 0 DFD or context level DFD we say. So here you can see there is a picture which is revealing you the smart home, okay, safe home software, where we have a control panel and sensors. These are sensor status, user commands and data. Here the control panel display, here is the alarm, and here are the telephone line. Okay, now if you observe this, this is called as the first data flow model we say, where this have only the main process, only the main process is present. Okay, I mean to say the further refinement into the depth or into the lower levels will happen in DFD 1 diagram. Clear? We see the level 1 also. So now we can see the level 1 diagram, the DFD level 1 we call. Here it is represented. So you can see the more refinement you can observe in the level 1 DFD rather than level 0 DFD. Okay. So whatever the process that is represented at your level 1 DFD, this also can be further refined into lower levels where the continuity of information flow will be maintained. Okay, so there are various things: interact with the user, control panel, then configuring the system, activation or deactivate the system, processing the password, display messages and status, here sensors, monitoring the sensors, telephone line, alarm, control panel display. Okay, so further refinement have happened. You can see this is the difference between level DF is level 0 and level 1. Got it. So as the level crosses, you will have a more detailed description of this. Clear, students? Then class-based modeling. So class-based modeling in UML is a core part of object-oriented design. So here we try to focus on representing the static structure of a system using classes, their attributes, methods, and relationships between them. So key elements, class, relationships, association, multiplicity, aggregation, composition, inheritance, or we say generalization also. Okay, so these are the key elements of the class-based modeling we say. Okay, so what exactly is class-based modeling? So class-based modeling is a core part of object-oriented design. Okay, it is used to describe the structure of objects in the system. Clear? So now a class will represent a template or a blueprint for creating the objects. Okay. So the key components are already discussed here: class and relationships. Okay. And there are a couple of relationships which are mentioned here. So these are modifiers. Plus is indicating the public, minus is indicating the private, and hash is indicating the protected. Okay, so you can see this in a diagram as well. So these are associations and dependencies. So association relate with multiplicity. So if perfect examples are also given, please look at the example: the wall segment, window, and door. Okay. Then associations and dependencies. So this is the dependency relationship. Okay. So display window, access camera, and password. Then example of a class diagram. So you can see all things are mentioned here. Okay. So you can see the modifiers are also mentioned inside the diagram. Okay. So animal, duck, fish, zebra. Okay. So now you can see age, int, gender, string. So is mammal, mate. Okay. So big color here, size in feet is wild. Okay, zebra is wild. Whether boolean is the value assigned. Then swim, quack, swim. This can run. Clear? So we have all things that are mentioned inside this. Okay, the attributes or operations, methods. Okay, the name of the class, objects, all things are mentioned here. Next is a behavioral model. So the behavioral model indicates how software will respond to external events. So types of behavior model, use case, activity, sequence, and state. Of course, we have seen a couple of diagrams in our previous video lectures as well. Also, but we'll just go through them. Use case diagram. So this model will capture the user interaction within the system. Now you can see this is a food critic actor. This is chef. So whereas the food critic can eat food, pay for the food, and he can drink the wine, and the chef can cook the food. Okay, so you can see the relationship that is mapped from chef to cooking the food, and whereas the customer or the food critic can do perform all these operations. Okay, the use cases, this is the boundary, and this is a actor. Then activity diagram, as I told you, an activity diagram represents the workflow or process flow of the system. So this is the starting point and this is the end of the entire activity. Clear? So here the activity is like filling the enrollment forms. Okay. Enrolling in the university. Okay. If it is incorrect, then help available. Obtain help to fill out the forms. Okay. So this is how the flow is. Attend university overview presentations, and enroll in the seminar, make initial payment of the fee, then end the process. This is the entire activity. Then the sequence diagram. A sequence diagram illustrates the interaction between objects in a time sequenced manner. Okay, this is example we have seen in our previous video lecture as well. Okay, user, device, database. More based on the mode of the user, the playlist will be generated. Then it's state diagram. A state diagram shows the various states that an object or system can be in and how it transitions from one state to another due to specific events. Okay. So now this is the start and this is the stop. Okay. So here the card is swiped and we are waiting for the pin. Now pin is entered or whether the pin is rejected. The pin verification happens and if it is authenticated, then ends. Okay. Thank you, students.